Hello and welcome to yet another video. Today we have something we never had before. We have a Biostar board. This is the very first Biostar board I'm working on. This is an H410mh. This is a very small form factor board, as you can see. It's really tiny. And the interesting thing about this board is that this has problems with its USB ports. I don't know if the board boots up, but I guess it does because the owner just said that the USB ports, all of them, aren't working. They said they have plugged in a faulty USB cable of some sort, and then some of the things burned. Like, they included in a picture. Let's go under the microscope together instantly. They have included this under in their description. These are 0 ohm resistors, or supposed to be 0 ohm resistors, that are burned up. So we are going to see what happened to these USB ports and if we can save them, because it seems that all of them aren't working, which is 8 different ones. There are, let's see, 2 here, 2 there, 2 USB 3.0 there, and 2 more on this one. So let's see. I would instantly go to the controller. If there's a controller, this is probably for the VGA in controller. But there's often an S media chip somewhere close. Let's see. This is a Realtek chip. This is probably for audio. This could also be for that, but it could be for USB. And all of these chips look quite fine, so I wouldn't expect any of them, but those resistors are probably dead. Let's get my multimeter. And now let's see, in resistance mode, this is the resistance of my probes. It's basically 0. So let's see, the first resistor right there. And can I get even a reading? Yep, about 20 mega ohms falling right now. So both of the resistors are dead. So these probably need to be 0 ohms. I'm going to see if I can find a schematic. I've never had to search for a schematic of a Biostar board, but we're going to see and find out if I can get one. I wasn't able to find any board view actually for this board. I have actually didn't find any board view for H410. So what we're going to do is we're going to see what processor goes into here. We're going to boot it up and we're going to see how the USB ports behave. I have a USB tester and we're going to see how that behaves in here. And now we are fully boot up. So let's see what we can see here. We have very low power consumption. 30 to 60 milliamps, that is very, very low. For standby, that is okay though. Let's find the jumper now for power on. No. Okay. But it does not seem to be able to boot up. Interesting. So let's see when we force PS on. Okay, I'm forcing PS on by shorting the pins on my power supply, but there doesn't seem to be happening anything, so this isn't trying to boot up or anything. There are no postcodes running. It's just taking dead current. Nothing getting hot. There's also very little current, only 370 milliamps. So that doesn't give us anything. And now the board booted up for whatever reason. Very interesting. Okay, we actually get postcodes. AF. I would connect the USB keyboard to here. Let's try to connect that. So we currently have very interesting behavior. This board actually goes through postcodes and seems to be booting up. Takes good current, but it restarts on its own. So I don't think it's actually booting up. I think we have some sort of problem with it. I cannot get VGA out. That might be a problem with the onboard HDMI. So what we're going to try now is we're going to turn this off and we're going to see if we get any life out of it with an external video card. And what I've done is I've gotten a PS2 keyboard and attached that to the keyboard port to see if that gets any life out of it or if that is also dead. So interesting now is we again get no life out of the power on. So I'm shorting the same two pins that I've been shorting before, but those don't have any reaction now anymore. So what we're going to do, let's short this again. I've now shorted PS on again. Now I've taken PS on off. And now let's see. Now we're going to start it again. Now it has a reaction to the power button. And now let's see if we can get any difference out of this. And as far as it seems, we have nothing. So we still have absolutely no reaction after bridging those 0 ohm resistors. So what we're now going to do is we're now going to find out if we have anything on any of these USB ports. For that, we're going to be using this USB amp meter. And we do have 5 volts on here, as you can see. It is sadly on its head for you, but there is 5 volts on there. Let's plug this one in. Yeah, this is also the other way around. And it also reads 5 volts. So the 5 volts is being provided there. So I don't think this is our problem anymore, that some of the USB ports aren't working, because they all seem to have their supply voltage. Yup, all of them are showing their supply voltage. So I think what actually is the problem right now is that we don't have 3 volts standby. That is the big problem right now. And we need to find out where that is being created and why it isn't being created. So for that we need 5 VSB, and from there we need to go on to 3 VSB. So now, to be better to show you what is happening with our board right now, I got out the PCIe riser, connected to them, to our PCIe postcard. So what you can now see is very, very low current, and the current is jumping just a little bit. You see the lowest LED right there. This is the 3 VSB LED. That thing has to be always on as soon as the 24 pin is connected right there. So we're missing 3 VSB, and as soon as we short PS on the main board, you see the light. This light that you see above is PCI reset. So that means this thing started up, but PCI reset is constantly applied because the normal boot sequence is not being initialized. So what we need to do is 3 VSB is now going to be charged, and now we can just hit the turn on button, the power on button, and now you can see it started up, and we have 3 VSB. So the thing is, as soon as you start a board, 3 VSB is being exchanged for VCC3. So the 3.3 volts is going in instead of the 3 VSB. And that is why our board gets charged up on 3 VSB and then can start up. But the original 3 VSB that should be started by 5 VSB is not being created. And before we didn't have picture, and the simple reason was because of the RAM stick. The RAM stick wasn't, in the first slot, it wasn't recognized. So all we had to do was to try to fix the 3 VSB. And what I haven't shown you, there's a small fuse down here, a poly fuse, that was also a 3.3 one that was blown. And I replaced that, or not replaced, but I just bridged that. So, and that is close to the BIOS chip, so I think that might be something related to the BIOS on the bottom right here. But right now, as you can see in the top right there, you can see we have picture actually at the moment. But we haven't resolved the original issue that 3 VSB isn't starting on its own. Right now, the mainboard is fully functional, or I guess not completely fully functional, because the 3 VSB isn't working by itself. But we have an indication on the keyboard, on the USB keyboard, and as you can see, I can change stuff here. So that works. I will need to find out if the other RAM slot actually works or not. We're going to do that. Let's turn the board off now. And as you can see, the 3VSB went off already. Let's see when we swap in a different RAM stick if we still can boot up or not. Let's see if the 3VSB is still charged enough. Yeah, it's still charged enough for it to turn on. So let's see if we get recognition of this RAM slot and if this board boots up again, or if we're going to get stuck in the same loop that we had before, where it wouldn't start up with a RAM stick in the left slot. And as far as it looks, we do not get recognition of the left slot because the board hasn't booted up yet. Let me quickly, in those cases, what I do, I turn this off and I turn off the power supply. I take the RAM slot out that is in question, that is not working. I use IPA, this is in this bottle. I go onto the context of it, clean the contacts on both of the sides. And then what I do is I take the RAM slot and insert it a couple of times and take it out. Make sure to give good pressure, take it out, put it in, and do that multiple times to clean the contacts that are in the slot that you cannot see, that are gripping onto the RAM itself. Now, you saw what I've done, or how many times I've done that. Now we're going to turn the power supply on, and you can see again the very low consumption. Now what we're going to do is again short P is on. So we're going to have 3VSB charged. We're going to hold it for a little bit. And now let's turn it on. And we can see 3VSB being applied. And let's see now if we now get recognition. And as you can see, we have no post still, so that seems to be not the problem. Let's turn this off again. So it's now turned off. Let's now remove that RAM slot once more, on that RAM stick. And now let's hit it again. It tried to turn on, but our 3VSB is discharged. It was too discharged. So our 3VSB is discharged right now. So what we need to do is we need to short P is on again with ground. And now our 3VSB gets charged up again. What we're going to do now, we're going to let go of that, and then we're going to hit the power button to initialize the normal start sequence. And as you can see, it's instantly booted up. Let's see now, it's now turned off. Let's get our DDR tester into here, and let's see what kind of signals are missing. And right now, let's see together if there's any LED that is missing. And yes, I can see a single LED that is missing. These in the middle I don't think are supposed to be on, but there's a single one down there, single LED down there that is not on. And a good test is to wiggle it around and see if there's any change in that. But as far as it seems, that contact is completely broken. So we will have to find out why that isn't connected anymore. And right now, you can see that the LED is on again in the top slot. I was actually first going around the slot looking for some damage traces, then went onto the backside. But what did the trick for me in this case was rather simple, was just a reseating of the CPU. That can happen very quickly. I can show you it, kinda. If you would look at the LEDs, if I release the latch, you see how many LEDs are already off. How many of these LEDs came just off because of the pressure. And as you can see, as I increase the pressure of the CPU, you see more LEDs making contact. And as soon as I have it fully down, you can see all of our LEDs that need to be on are on. So let's turn this tester off again. And let's try that once more to see if both sticks of RAM are being recognized. And this is a pretty annoying issue that you can have, but through diagnostic process you can eliminate it quite quickly, that there's just a bad seating of the CPU. So we're now going to try this again. We're now going to turn the power supply on. Let's see now. We need our VGA and our power cables on here. And now I can show you again with our PCIe tester. Same thing as we had before. You can see we have no 3 VSB. We're shorting PS on. It turns on. We have 3 VSB. And now turning it on normally. And we're going into boot. And let's see. I have the device disabled for video capture. And as you can see, we're now booting up with 2 RAM slots. So that wasn't an actual issue. That was just a reseating issue. So that is also solved. So we now need to look into placing a CPU in here, and we need to find out how 3 VSB is being created on this board. We sadly don't have schematics that would make it way easier, but I think we can figure it out together how 3 VSB is being created, and we can figure out why it is not being created normally like it should be right now. So next thing is, because we know that we have a problem with our 5 VSB and our 3 VSB, we continue on to search from the slot on, from the 24 pin slot. So we know that the 4th pin from the left top is 5 VSB. And what I found is that close to this slot there are 2 fuses right there. And we're going to go under the microscope together and we're going to look at those fuses. And you can see very clearly that these are connected to the 4th pin. So I'm going to go into the 4th pin and to the fuses. And you should be able to hear my multimeter beep. So these are connected. But those fuses, I can show you, this beeps. But if I go into those fuses, there's no continuity on there. So these fuses are both blown. These lead to the same way. So these are 2 fuses in parallel, which increases their maximum amperage. So this has continuity, but this doesn't. This might be already the solve for our problem that our 3 VSB isn't running correctly. What I'm going to do, I'm going to bridge those connections like I've done a different one. As you can see, we have the BIOS chip right here. And next to it, there's also a polar fuse that you can see right under there. And what I've done is I've just used some braid to bridge it so that the fuse is bridged, but we have a connection through there. The same thing I'm going to do for those poly fuses right here. And I'm going to see if I'm going to have we're going to see how the 3 VSB behaves afterwards when we do this. But first thing I want to do is I would want to check the other side for a short circuit. I don't think there will be one, but you want to do that before bridging a fuse. But the other side has 11, 12 kilo ohms and rising. So that is fine. We can bridge those 2 contacts together. And then we're going to see how the board will behave afterwards. And right now, the fuse is bridged, and if we now use our multimeter in continuity mode or beep mode, we're going to go onto one side of the fuse and going to go on the other one, and we now have continuity. And now let's see if our board behaves any differently and if our 3 VSB is now running. So now let's see, going to turn this on, and it doesn't seem like we have 3 VSB built, because as you can see, we have nothing there and we still have no reaction on the power button. So that wasn't the case. So let's see if anything changed when we bridge our piece on, if this behaves any differently or if it's still turning on the way we thought. Yeah, so we have no change in that behavior. I cannot really say to you what these were supposed to do, those poly fuses, what they bridged together or what they were responsible for. Let's see, the board doesn't turn on right now because we have no RAM installed, so let's quickly do that. So now with RAM installed, let's see if we can get a picture out of this. And as we can see, we're still booting, so that still works. CPU has no heatsink, so I'm going to quickly turn it off again. So that wasn't the resolve of our issue. We're going to look further into this now. We have to find out where our 3 VSB is coming from, or where it's supposed to be created. And we're going to be using the 5 VSB as a reference, because our 3 VSB is created through our 5 VSB. And we're going to see if you can follow the path of 5 VSB to somewhere where 3 VSB should be created. So, what we're practically going to do is we're taking our multimeter, and one thing I've already spotted out before where 5 VSB goes, when we go into beep mode, one probe into 5 VSB, and it goes right there to this regulator right here. This is a linear regulator. I can show you that under the microscope. And now we can see the regulator. There's also a fuse close to here. Let's see if that fuse is blown or not. And as far as it seems, this fuse has also blown. Let's get you a little bit down here so you could see that. So this fuse, I have no continuity through it. I don't even get an ohms reading. Oh, now I might be getting one. Almost a kilo ohm of reading. So this fuse has also to be bridged. Seems like every single poly fuse on this has blown, because they're all on the 3.3 volt line. But those fuses have done a very good job, because nothing important, nothing big is killed. Like our PCH survived, our BIOS chip survived. So all of these fuses have done their job very, very well. So I'm going to bridge that fuse, and we're going to see if we have difference. And now we have that poly bridge, that poly fuse bridged as well. Let's get a look again if our board now behaves differently, or if there's yet another fuse somewhere that I've not seen. And as we can see, just by the power consumption alone, you can already see that 3 VSB isn't running, because it is trying, but it isn't going up. And if I try bridge the contact of the power button, we still have no reaction. So that also wasn't the culprit. Very interesting. We need to find out yet more why this isn't working right now. So let's see now. Let's go into voltage mode. We've seen that regulator that was close to that poly bridge. So we know the very left pin right there is 5 VSB. So this pin right here shows 5 volts. So let's see. The middle pin shows 3.3 volts. And the pin on the very right shows 2.08 volts. So I think that one works fine, because we have on this one, which is most of the time the output, we have 3.3 volts. So I think that is what we are supposed to have right here. So, and now after all of those fuses that we've bridged and still no change, we now go through 3 VSB directly. So right now our probes are in continuity mode, and the very first pin, or the very last pin there in the bottom, should be connected to that one on the other slot, and this is 3 VSB. So we are going to be using that pin to try to search for the 3 VSB regulator. So we're going to see wherever this pin connects to, we need to have a look at that situation and see if there's a regulator there that carries this signal then. So I think I've found something that is important to us, because we have on this regulator right here that we can see, as soon as we apply power to it, we have on its output, which is this right here, I believe, we have 2.4 volts. This might be also its input, I'm not too sure, but this is a big trace. This is a big trace. The upper one had 0, this one has almost nothing on it. And this big trace that is coming in here has 2.4, 2.5 jumping around. And this same trace connects to this regulator right here. And this regulator also behaves quite weird, because on this pin, which is the connector pin, we have the 2.4, 2.5 jumping. On the upper pin right here, we have a jumping voltage of 1.6, 1.4 jumping around. This is the same as this one in the middle. And to this one, we have almost a volt, jumping from 0.9 to 1 volt. So I think something related to these two components is wrong. So what I'm going to do is I will be looking up the data sheet for this chip right here, and I'm going to be looking into what is the input, what is the output, and what this chip does. So I've now looked at both pinouts of these chips, and for this is its input, which is 2.5 volts. This is its output, which is 1.4, 1.5 fluctuating, and this is an adjust pin. So this is for, as you can see with the two feedback resistors, it adjusts the voltage that it's putting out. So this is not the culprit. And also on this chip right here, I was able to find online, the pin that we were looking at, which is this one, is its input. So on its input we also have 2.5 volts and fluctuating, and this is its output, which has nothing on it. So these two are not responsible for our problems, because they too take this 2.5 volts as an input. So I think these 2.5 volts that we see are supposed to be our 3.3 volts that are not correctly, that are still 2.5. So our search continues. So I have to do quite some catch up on this one. This has been a roller coaster of surprises, and this board has taken me for a good stroll. Like, I've been misled very heavily by this. You remember the fuses that I talked about? Those were not polyfuses. Those were rectifier diodes. Schottky rectifier diodes in order to protect some circuits. So, in the bottom right here, what we had, this is a Schottky diode. I only had the reading in ohms, which was very high, and I thought these were polyfuses. I thought these things were the same one like those ones, but they are not. These are protective diodes, Schottky diodes, and when you read this in diode mode from there to there, there is actually a diode junction. So these were working normally. Guess what I did at other points? I did the same thing here. This one isn't cleaned up, just there's a lot of flux on it. I did the same thing here, and I also did the same thing there. All of those points were bridged before, which was a big mistake by me, but I very luckily haven't killed anything. And I also got the impression that it was wrong because of this symbol. This symbol that you can see right there is the symbol of a diode, pointing that this side to this side is continuous with the diode junction. I have been misled greatly by them, but now I know there should be protection diodes there, and all of these diodes survived without a problem. On this side, on the left side of the USB, there was actually a problem with the 0 ohms. There was no problem that I bridged that. And then this board threw a very, very interesting problem at me, because this board requires quite some voltage on the 5 VSB line. And I showed you that problem before. Because I have tried to dig into this 5 volt VSB circuitry so deeply without a schematic, just with the schematic of a H410 board of also Biostar. I've been going through it over and over again, trying to figure out why my 3 VSB auxiliary, which is on the PCIe slots, wasn't consistent. And it wasn't consistent because I have high current draw on 5 VSB on this mainboard. So this mainboard has about 0.5 of an amp of current draw on the 5 VSB line passively. And that is too much for my tester, for my 12 volts to PCIe to 24 pin adapter. I can show you that right now. So right now we have my 24 pin adapter, and look at the amperage right now. If I plug this in, you see 40 milliamps. 40 milliamps of 12 volts, and the regulator, the 5 volt VSB regulator on my adapter starts to burn up. So this draws too much amps on the 5 VSB for my regulator. And I thought there's actually a problem with my power this mainboard still, because I've never had that on any other mainboard before, and I spent hours and hours digging into this board. As you can see, if we go under the microscope, right here you have the main circuitry for the 5 VSB and the switching. It comes in, let me get something to point at. You have it coming in from this side, it goes through this protection diode into these two MOSFETs, I think these are, or maybe these are transistors, and then it also switches with this transistor into 5 volt dual. And then also from this side it goes to many different ICs. It, for example, goes to this linear voltage regulator, and it also goes into this one, and it also goes into this regulator, it also goes into this one. And I've been searching high and low for an answer why I was drawing so much current. But the actual answer is I wasn't. My tester isn't made for that kind of current of 5 VSB, and I'm not quite sure why that is. Because as soon as I switched over to a normal ATX power supply that is able to deliver 2.5 amps on 5 VSB, everything started to work normally again. So the original problem with this mainboard was actually just the USB not working because of the burned up 0 ohm resistors. Everything else that I've done on this board was placeboed by the fact that I thought that these rectifier protection diodes were fuses and were dead, and that my adapter showed that there's too high of a power consumption. So I was misled by a red herring super badly. So what I'm going to do now with this board is actually going to build it up using the power supply that I have, and I'm going to start it all, and I'm going to see if everything else works out normally. I'm going to test all of the USBs with data also, so I'm going to put in USB stick and see if that can get read, and going to see with the second stick of RAM and the SATA and the NVMe. But I think there isn't going to be any more problems with this. So thank you very much for watching. Be cautious out there when you're fixing something, that you don't get misled by a red herring or by even equipment that isn't working properly. So always have something spare or backup that you can use as an alternative to fact check everything, because I have spent, I think, 5 or 6 hours on this board, and it is definitely not worth it. But I just wanted to understand why this wasn't working properly, and now I understood, because my tester didn't work as intended. So thank you very much everyone for watching. Have a good day. This has been Mainboard Medic. Thank you very much, and goodbye.